This is the guts of a Lutron high lume A series constant current LED driver that I got a couple of months ago and just got around to doing a guts video of. I don't really care about the fact that I'm going to have to use this as a bare PCB because I kind of grunched the case because I got this for next to nothing at about the same time I got the, actually got it from the same place I got the that N-phase thingamajig I did a teardown of a few months back. But anyways, it's typical, it looks to be a fairly typical constant current switch mode power supply, which is again what you use for driving power LEDs, because LEDs are constant current, not constant potential devices. Although this does have things like it has a dimmer input, which is that orange thing. Takes regular non-dimmed electricity through the hot is the black, dimmed hot is orange, white neutral, green ground, and these two purple connections are a digital bus. It says ecosystem bus on the thing. I'm guessing it's probably some kind of a differential signal or something. Possibly ground or neutral referenced, though I don't exactly know because I don't have one of these systems to do analysis of, not to mention my I don't have anything like a DSL that can do all the fancy triggering necessary. But anyways, couple of common mode input things. Actually, this is a looks like two common mode filters on one core. Judging by the position, it's a 4-layer board, so I can't trace a lot of the wiring on this thing, but judging by the position, I guess that one of these is for the bus thing, just to keep out common mode noise in either direction, and the other one is just for the mains input. And down there's a Bell fuse 3.15 ampere plastic cylinder package fuse. There's that. Surface mount 680 microhenry, I think, choke. Don't know what that's doing. That might be just for mains input filtering. A couple of I think those are no, those are red things are varistors. A couple of caps which I kind of grunched because I had to drill out a rivet. But I think those are just suppression. It looks like it didn't show up any inner traces in the board, so I'm just going to resolder those before I use it. A couple of power devices, the switching FETs, bridge rectifier, another cap for ESD suppression, that cap which looks to be crossing an isolation barrier. So that's just the Q-arm suppression thing. Because for high frequency noise, the main supply is effectively ground, and that's just to keep any lethal lines potential or mains potentials off of the output and killing people, which would generally be bad. Those are a bunch of power. Those are a bunch of resistors, obviously a current shunt of some sort. Those are okay, so those are 1.02 ohm resistors. So again, that's just a bunch of them in parallel as a current shunt, or for current sense shunt. This sticky pad of some sort on top of the main transformer. A couple of lytics. They all look to be all the ones I can see branding on their United Chemicon, so reasonable. Yeah, that's United Chemicon. So again, reasonable quality stuff, no obscure Chinese rubbish. That's the main output cap. Turn 21 degree Fahrenheit rated, which is good. There's a transformer. Shindy PRC. Okay, so it's Chinese-made transformer. Week 41 of 2011. One interesting thing about this is that there's this. Since most people can't read upside down, this thing has a date code of June 12th, 2011 on it. But week 41 of 2011 would be in would be in October sometime. So I don't know if it might be just when this label was printed, and they print up a whole bunch of these things and they was sticking on the thing when they made them, or if they made the cases in advance and just didn't populate the PCBs till later, but there's a couple of other date codes after that June 12th date in here. A bunch of optos. Again, I'm guessing that's probably more isolation barrier stuff, so that this ecosystem bus or whatever is isolated from mains or whatever. And there's another bridge rectifier down there. I don't know if this bus might also provide power or something to that part of the circuit. Then there's that. It's an semiconductor RBJH. Guessing that's probably a regulator of some sort. Bunch of SOT23-6 devices down there. I'm guessing those might be, I don't know, amplifiers, buffers, something of that nature. Another probably wait, Q. Oh, those are just transistors, so those might be external pass transistors for something. Obviously, those two are the main switching devices for the power supply. There's another international rectifier, L29I or L29105. That is Q17, so that's another transistor. That might be switching transistor for PWM output. That actually might be what that is. That's probably an output PWM transistor. And but anyways, see if there's anything else interesting on this side of the PCB. That's the might be a that might be actually another something like an anti-parallel or no anti-series. You can get bidirectional avalanche diodes for ESD protection, so that might be something like that, which in conjunction with Varistor is probably a fairly decent solution, because MOMs on their own are just the lowest end of the methods of, or the least durable of the various methods of surge protection. And on the other side there's Z1, that's a little fused device. I'm guessing that's more ESD protection. A bunch of various SO8 package devices. I'm guessing some of these probably might be amplifiers or buffers of some sort. I know at least some of them are going to be FET drivers. I haven't looked up many of these, but there's another FET. International rectifier LR8743, another device. I've had a bit of a cursory poke at this thing, and or at least look around. A lot of the silicon is ST micro, but that's going to be the main charge controller, or main controller device. That J3, that's probably just a JTAG ICD port, because it's not externally accessible, and obviously you wouldn't use something that small and flimsy in a building connected application where you're going to have contractors just checking these things in toolboxes and harping things together. It's another ST device, S912I, I think. So I can read things upside down, but most of the people watching this can't. So the EZ137, that's an ST micro. 32P103C6. Yeah, it's micro of some sort. Another SOT23-6 device there. Don't know what that is. There's the crystal. All their devices, which might be buffers of some sort. Another ST device. EZ040. That's a Texas Instruments KY5133. Don't know what that is. Might be, I don't know, active filtering or something. A bunch of caps around here. Device. Q, that's another thing. U12, which is, I don't remember what that type of a package is, but it's one of these ones where the solder terminals are on the bottom of the package, so it's like some kind of a LAN solder device, or solder type connection device. but the solder legs extend up the side of the package so that you can visibly inspect it, because you get solder wetting up the side of the package if the thing's properly soldered. That one's AUF 1A plus. Is that a cap? Huh. Oh, it's obviously not a capacitor, but you don't know what that is. Mystery R301s. Okay, those are 301 milliohm things, all in parallel. So that's another current sense shunt. And here's with that, which might be, I don't know, more PWM stuff, but I don't know. Let's I don't know. Can't really trace out the circuit on this thing. Because again, 4-layer board. Okay, okay, a bunch of 464,000 ohm things. So that's going to be a potential measurement thing, and they've just got a bunch of resistors just to spread the load out. And of course, using the same value for each one, which is good, because I've seen some horrible Chinese stuff where they use a whole bunch of different resistor values for dividers like that, which is stupid. But then again, made in China. So that's just a random thingy.